2.5, continue part C. So we're going to do an example. Find the points on the graph of f of x equals x cubed minus 3x squared plus 1 at which the tangent lines are horizontal. I'll read that again. Find the points on the graph of f of x equals x cubed minus 3x squared plus 1 at which the tangent lines are horizontal. Okay, we're going to make kind of like a loose graph of what this looks like just so you can have an idea of what we're dealing with. So draw a graph here and just go up to 1 here and go out to 3 here. Okay, and then we're going to go down 3. 1, 2, 3. So we have 1, 3, negative 3. Okay, once again, this is just a loose graph of this equation right here. If we put a 0 in there, we're going to get 1. Okay, so make a point there. Also make a point at 2, negative 3. Okay, and once again, this is just a loose graph of what this looks like. We have something like this, and then up. Okay? All right, now why we drew that picture is because it says, find the points in the graph at which the tangent lines are horizontal. Well, what would that be? At this point right here, we have a tangent line that's horizontal. Same thing here. We have a tangent line that's horizontal. So when a tangent line is horizontal, what's the slope going to be? That's right, the slope equals 0. Slope equals 0 for these tangent lines. Okay, so I'm just going to draw on these tangent lines. All right, so this graph is f of x, and these are our tangent lines at some points, okay, where the slope equals 0. Now it says find the points. Well, if we couldn't see this, I just wanted to show you what it looked like. How would we solve for that? Where we just said, well, where the tangent line is horizontal, the slope is 0. So f prime of x, when we take the derivative, that is the slope of a tangent line. So we're going to set that equal to 0. Okay? So we're going to first find f prime of x. We're going to set f prime of x equal to 0 and solve for x. So let's take the derivative of this. F prime of x equals 3x squared minus 6x. All right, we set that equal to 0. All right, now we're going to factor out what they have in common to solve for x. They each have a 3 and they each have an x. So I'm going to factor out a 3x. 3x times what is 3x squared? We need an x. 3x times what is negative 6x? We need a minus 2. All right, so now we solve these. 3x equals 0, or x minus 2 equals 0. X equals 0, or x equals 2. Okay, so, and look at this. At x equals 0, the graph has a horizontal line, a tangent line at that point. And x equals 2, 1, 2, same thing here. All right, but what was the question? Find the points on the graph at which the tangent lines are horizontal. We found the x values, we need to find the y values. So we're going to find f of 0 to find the y values. And once again, we said if we put zeros in there, we just get 1. So there's 1 point. 0, 1 is 1 point. Let's find the next point. We're going to put a 2 right in here. So f of 2 equals 2 cubed minus 3 times 2 squared plus 1. So we have 8 minus 12 plus 1, which equals negative 3. So our second point is going to be at 2, negative 3. So there's our answer. We found the 2 points at which the tangent lines are horizontal. Okay, let's go on to our last discussion. in this section. Okay, we're going to look at higher order derivatives. Higher order derivatives. Higher order derivatives. Now it sounds like it's complex, but it's really not. Here's an example. If we have f of x equals x to the fourth, and we take the derivative, we have f prime of x equals 4x cubed. Now what if we took the derivative of the derivative? So we have a second derivative. F double prime x, we take the derivative of the first derivative. So we have 3 times 4 is 12, x squared. Okay, so that's all higher order derivatives is. Now how would we write that? You might see it something like this in your homework. D dx, and then they put a little 4 there. That means we're going to find the fourth derivative, and they're going to ask something like this. So here's a question. We're going to find the fourth derivative of 2x to the fifth. All right? So if you want to rewrite this so you understand a little better, we're going to say f of x is 2x to the fifth. So we're going to do f prime of x. That's the first derivative, which is 10x to the fourth. Then we're going to find the second derivative, which is 40x cubed. Then we're going to do f triple prime x. That's a third derivative. 3 times 4 is 120, x squared. And because of this 4, we're going to go on 4 prime x, the fourth derivative. 2 times 120 is 240x. See? Isn't that kind of fun?